In these examples, we will explore a few other quadratic models, particularly the position function. So for this first one, this is not obviously the position function, but they have already given us the quadratic model, which is right here, where E of X represents in dollars average weekly earnings, and X represents the number of years since 2010. So we're asked to do two things. The first, determine the average weekly earnings in 2015. So I know that I need to plug in some value for X, where X represents the number of years since 2010. Obviously, there have been 5 years since 2010, so I'm going to find E of 5, meaning I'm using this function, and everywhere I see an X, I will replace it with a 5. Now that I've plugged in my values, I'm going to use a calculator to help me simplify each of these terms. And now that each term is simplified, I'm going to combine those three terms together to find E of 5. The question asked for the average weekly earnings in 2015. I found a value of 615 and 5/10, which means, of course, that the average weekly earnings is $615.50. The second question related to the same model says, in what year will the average weekly earnings reach $940? So right now, in 2015, the average weekly earnings are 615.5. We're asked, in what year will that reach 940? Instead of replacing the X with a value in this case, I'm going to replace E of X with a value, in this case the value of 940. So 940 equals 0.14x squared, etc. So the X in this case is what I'm solving for. Whenever I'm solving for X in a quadratic equation, I can factor, I can use the quadratic formula, etc. In this case, because I'm dealing with a lot of decimals, I'm going to use the quadratic formula because I know that it will give me the correct answer. First, however, I need to subtract the 940 from each side so that I have 0 equals. So I've subtracted 940, this is my new equation, and now I'm going to use the quadratic formula where A is 0.14, B is 7.4, and C is negative 365. I don't have a lot of room here, so I'm going to just give you the shortened version of the quadratic formula. X equals the opposite of B plus or minus the square root. Finding B squared minus 4AC gave me 259.16 over 0.28, which was 2a. The square root of 259.16 is about 16.098. Remember, to find my solutions, I will take negative 7.4 plus that value divided by 0.28 and then subtract that value and divide it by 0.28. I know that I'm looking for a year, and so having a negative value would not make sense at all. So the only one I'm going to worry about is negative 7.4 plus 16.098 divided by 0.28, and that gives me 31.06. They're asking me in what year this will happen, and of course I then need to look at my 31.06 and know that that means years since 2010. So the year would be 31 years after 2010, so 2041 is the year that we would expect average weekly earnings to reach $940. This next example has to do with the position function, and the position function is right here. So let me explain the parts to you quickly before we actually do a question using the position function. S of t represents the position of an object that is being shot in a quadratic method. So basically we're saying we've got, say, something being launched from the ground, it would go up, it would come back down. That's in a U shape or a quadratic shape, which of course means that we're going to have that squared value. So S of t would be where is that object, how far above the ground at any point in time. S of 0 represents where it starts. So here, if I was launching, say, a rocket from the ground, S of 0 would be 0 feet off the ground. V sub 0 is the initial velocity. So at what speed did you first launch the rocket? or in this case an arrow. G represents the acceleration due to gravity. If you're dealing with a question with feet per second, that would be 32 feet per second. If you're dealing with a question where everything is in meters, you would use 9.8 meters per second. So I'm going to use that to write my function. For my question below, I'm taking -1/2. Because everything down here is in feet per second, I'm going to use 32 feet per second for G. T is my unknown. V sub 0 means the initial velocity, which in this case is 20. Speed and velocity, those are the same. S sub 0 is the initial starting point. This arrow is shot 6 feet off the ground already, so that's the +6. By simplifying that a little bit, the function I will use is -16 t squared plus 20t plus 6. That is your position function for this particular question. In addition, it asks me to find the time it will take for an arrow to land. So then we have to ask ourselves, when the arrow lands, what do we know about it? Well, we're trying to find the time, which means we're solving for t. S of t is the position, how far off the ground it is, and if it's landing, that means that position is 0. So 0 equals -16t squared plus 20t plus 6. For this particular question, I see I've got a lot of whole numbers, which is nice. I might try to go ahead and factor this. I'm going to take out a common factor first, and whenever I have a negative in front of my leading coefficient, I'm always going to take that out. In this case, I also see that all of my values are even, so I'm going to take out a -2 rather than just a -1, which leaves me with positive 8t squared, a -10t, and a -3. I'm then going to factor what's left over. So my -2 will stay on the outside. Here, I'll use that tic-tac-toe factoring or the AC method factoring that we learned last week, so go back and look at that if you need to. In this case, this would factor into 4t plus 1 and 2t minus 3. Again, you can always FOIL it back out to check it. I would get -12 plus 2. That gives me my -10 in the middle, so everything works out. Now, I'm trying to determine the time, so I'm going to take each of those and set them equal to 0. So this gives me that t is -1/4. And this one gives me that t is 3/2. Of course, I'm looking for a positive value because I'm dealing with time. This one does not make sense. So the time it would take for the arrow to land is 1.5 seconds, or 3/2 of a second, which is 1.5. Here's a similar question for you to try on your own. You must write the position function yourself, and then, just as we did on the last question, solve to find the time that the height of the mortar is 60 meters. So again, I'm going to start by writing my position function, which is s of t. In this case, notice everything is in meters rather than feet. So when I use my -1/2, I'm going to use 9.8 rather than 32 t squared. The initial velocity is 40 meters per second. The initial height is 2 meters. Do a little bit of cleanup there. And now I'm going to find, based on my little cleaned up equation, at what time, so again I'm solving for t, time or times, the mortar is at a height of 60 meters. So in our last question, the height was 0 because we were trying to find when it hit the ground. On this question, we're looking for the height to be 60, so I'm replacing s of t with 60. And then, of course, I can't solve unless it's equal to 0, so I have to subtract 60 to both sides. From here, I'm going to use the quadratic formula, which is t equals, instead of x equals, because we're dealing with t, the opposite of b plus or minus the square root. I'm going to go ahead and find b squared minus 4ac all at the same time, just to save time and space, which is 463.2, and then all over 2a. So that is my quadratic formula. I'm then going to find the square root of 463.2. And notice that it says round to the nearest tenth, but when I'm rounding this value, once I take the square root, I always round further out than the tenth. So I'm going to round this to 21.522. So it's best to give yourself a little bit of extra, because then when we round at the end, it's a more exact answer. Now in this case, I am going to go ahead and then use my plus and my minus. So t equals -40 plus 21.522 divided by -9.8. And that value rounded to the nearest tenth, so now I am rounding to the nearest tenth, is 1.9 seconds. I'm also going to try it the other way, which we didn't have to do on the last question, but notice that when I calculate this time, I also get a positive value of 6.3 seconds. So I did get two values, but let's stop for a minute and see if that makes sense. We know the fireworks are launched straight up. Obviously it's going to go in that quadrant, so we're starting 2 meters off the ground. We know that it's going to go up and then come back down. Their question is, when is it at a height of 60? And so that's up here somewhere. So it would make sense that twice, once on the way up and once coming back down, that the height would be 60 meters. Now obviously this is a firework, so we're assuming at some point up here, unless it's dead, that it actually did explode, and this one probably wouldn't make sense. But definitely that first one is at 1.9 seconds, and if it's a dud, it would also cross at 6.3 seconds.